Well, we're ready to start. Hello, my name is Lucio Garcia. I'm a PhD student at Sophie Lab at the University of Buenos Aires. And I'm going to talk about my work that it's called Characterizing Agendas and Information Gaps in Argentina's Political Discussion. So before I start to talk, I need to explore this phenomenon called gatekeeping. Gatekeeping is a process that happens when an actor, like a mass media or editor or influencers, filter and prioritize information, and that shapes the way that readers or users in a social media will consume that information. Since the arrival of social media, this process has become weakened because you may have editors, you may have journalists also being part as the readers in a social network. One case, the most famous case of gatekeeping, I think it could be Gandalf. But the point of this work is to propose an analytical framework for examining the public agenda and media agenda through analysis of the news disseminations using graph theory. Particularly, we are going to use social media. In particular, the social media we are going to use is X Twitter. So the tweets were collected from a database that was used in previous works, and that was collected by searching for specific keywords that referred to Argentina political elections of 2019. And it spans for a period of 7 months. There we are going to focus on build two weighted co-hashtag networks. So we are going to keep from the tweets all those tweets that possesses at least 2 hashtags to build a total network, and we are going also to discriminate those tweets that also possess an URL from an Argentinian media outlet. So you can see that here is the weighted co-hashtag networks, and here is what we call the L0 network, that is this also a weighted co-hashtag network, but with a hashtag that co-occurs with the URLs. So we have separated these two networks in what we can think of as a media debate network and a total public discussion network, right? So after having these two networks, we are going to perform them an algorithm, a latent community detection algorithm, to find them communities and assign them communities that now we are going to talk about them as topics, right? So what we are trying to do is to establish this comparison between agendas. So we need to label to pass the labels of the communities of these two networks to the tweets and to the URLs, so we can make a comparison. Since each URL or each tweet can contain multiple hashtags, we can think of them, we can think of that representation with the topics and with the hashtags as an hypergraphs. So we can see that a tweet here may have multiple hashtags that are associated also with different topics. Each hashtag, or in this case, an hyperedge, we assign them a community vector, where X is the name of the hashtag, and the community vector forms a base with the rest of the other communities that appear. So we are going to use these community vectors to define for the tweets and the URLs what is known as an alignment vector. That is the sum of all the community vectors that appears that co-occurs with those URLs, weighted by the co-occurrence. Since an URL can co-occur multiple times with a hashtag, we use that as a weight to ponder that information. And it's divided by the total strength of the node. Here, since we can think of hypergraphs as a bipartite network, here is an example of how it was done. This is for the URLs. You can see that the URLs have weights on the edges. And in the case of the tweets, since they are uniquely and specifically identified, you can't have weights. So instead of the strength, you will have the degree. And after doing that, we can assign the tweets and the URLs a vector of alignment to a specific topic. So, since not all the topics of the networks may talk about political discussion of Argentina, we had to make a specific selection of each topic. To do that, we analyze the word clouds and keep only those that mention a specific terminology of Argentinian elections. But not only that, we also notice that the most mentioned topics in both cases, in both networks, also are those that had the most size. This size can be thought of as a diversity in the number of hashtags, right? So what we do was to select them in order to later compare them. Here we can see this comparison. By construction, all the L0 topics are inside of the total network. Here we classify them as share or only public discussion. Share because if a community of L0 appeared in one of the in one of the topics of the total network, it was called a shared debate. If not, it was just only public discussion topics. What we can see here is that in blue, that are the ones that are shared, were the most discussed ones. That means that the topics that were most discussed were those that were traversed by the media. Since when we selected these shared debate topics, we wanted to see also inside of those topics which actor dominated the discussion. For example, if in this topic the media dominated the discussion or it was the public. In order to do that, we classify the users of X as media or as just regular users. So doing that, we can create the time series of that topic and discriminate them by these two actors. Performing an event detection algorithm, we selected those peaks, the peaks that were more relevant, and we took a window with plus and minus 1 day to see which one of the actors was dominating the discussion, the debate. So we make this raster plot. Even though those topics that were classified as shared, they were also dominated mostly by regular users. And one thing, after doing this, we also thought to see how long does it take news to impact in a debate, in a discussion, in a specific topic. To do that, we use the alignment of the URLs, alignment vector of the URLs, and calculated the published date of each tweet versus the published date of the URL that was posted on that tweet. Can you see that this zone is prohibited? And we can see that we have this kind of long tails that belongs to the 3 most relevant topics. This, in the other topics, they don't present these long tails with lots of outliers. So this may be a behavior where a topic is very long discussed in a very long time, and the users keep pushing this all news. Keep pushing this all news and try to argument in a recursive way using information from the past. So, conclusions. We observe that relevant topics tend to accumulate a higher number of hashtags, reflecting a broader and more diverse engagement. As expected, these topics are consistently discussed both by public and media agendas. And we identified topics that were not in the media agenda and found difference in the timing of the news publication across these topics. That is not what we didn't expect to see that. So we are now working to extend these results to an additional dataset here in Brazil. So thank you for your attention, and thank you.
Thank you. There are questions? I don't have a question, I just have a comment. So probably a possibility to understand whether it's the public that drives the media or the media that drives the public, you could consider tools like transfer entropy so that it's a directional information transfer matrix. So, so you could understand whether one is from one you can predict the other or vice versa. So that could be
I've already worked with transfer entropy, not in this time series, in other work. It's kind of difficult to work with this time series because they are not stationary, and I don't know if they.
Maybe you can detrain the stationarized time series.
We already tried to detrain them, and what happened is I think the fluctuations The fluctuations still bother to calculate them.
Okay, okay, I see. Thank you. There is another question.
What other data sets do you have to validate? Like other elections or other
Other
platforms?
They are elections of Brazil.
In Twitter as well? Or?
In Twitter as well, yeah. Previous elections.
Thank you. Let's clap again.